Okay, so for this one, we're trying to find the volume of the prism. It is a prism. Why is it a prism? It's a prism because the top and the bottom, well, in this case, the sides, but same basic idea. Top and the bottom are the same shape, meaning a triangle. What am I talking about? Well, this right here is a triangle, as you certainly know. And the back, if I can draw it very well, but the back right there is also a triangle. So top and the bottom are the same shape triangle, straight sides in between. So this one's a prism laying on its side. So it is a prism. A prism is something where you've got top and bottom are the same shape, triangle to triangle with, you know, straight sides, so straight sides in between. So triangle to triangle, straight sides in between. It's a prism laying on its side. You know, normally that triangle would be those two triangles would be the bottom and the top if you stood it up. Anyway, so how do we find the volume of a prism? Well, if we go to the notes, let me see if I can get that for you. There it is, right there. So there's the volume of a prism. Let me pop that in here for us. There it is. Okay. Okay, so to find the volume of a prism, you gotta take the area of the base times the height. B is the area of the base times the height. So like for a triangular prism, which is exactly what we have, it's going to be the area of the triangle times the height. Because the triangles are the top and bottom. Even if it's laid down on its side, you still focus on the triangles. Those are the bases. So area of a triangle times the height. So the prism volume, let's do that. Volume of a prism is area of the base times the height. And area of the base, what is the base? I'll say the area, yeah, in fact, of the, let me just add a word there, probably easiest, area of the triangular base, right? Because it's a triangle. So, okay, so how do we find, question becomes, how do we find the area of this triangular base? That's it. What's the area of a triangle? Triangular base. Well, a triangle, you know how to do a triangle. Triangle, it's base times height divided by 2. It's one side times the other divided by 2, right? Yeah, but what are those? And then over here, well, let's just stay with that for a minute. This is a tricky one. So then what are the base and the height? What are they exactly? Well, it's got to be the 11 and right here, the 5. See how the 5 would go right there, be the same thing? It's the 11 and the 5. That's the base and the height divided by 2. Why are those the base and the height? Because see the 90 degrees right here? So this is base and this is height of just the little triangle. And then the 15 is the height of the whole prism. So that's what's confusing is we have all these different base and heights now. Let me pop that over here. That it's kind of hard to keep straight. Do you see what I'm talking about? You have the height right here, the 5, which is the height of just the little triangle piece right there, right? Height, the 5. Right, so there's a couple of heights and a couple of bases going on. It's hard to keep all this straight. Once we go 3D, there's a lot of confusion because we have base and height in the 2-dimensional world and we have base and height in the 3-dimensional world. So this is the base and height of the flat 2-dimensional triangle. It's just the two sides that meet at 90 degrees, right? Base and height have to be 90 degrees. So that's 11 and 5. And that's how you find the area of a triangle is base times height divided by 2. So 11 times 5 divided by 2. And that whole thing is the base of the 3-dimensional shape, the prism, whose height is 15. Why is that the height? Because that's the distance, the height right here for the whole three-dimensional prism is the distance between 90 degrees between the two triangular bases. So there we go. It's kind of confusing. And so if you do that in your calculator, hit all the buttons. Let me see. I'm going to do it too. Literally, you just go, 11 times 5 divided by 2 times 15, and I'm getting what? 412.5. There it is, 412.5. And that's cubic meters because we're talking about how many cubes could fill up that three-dimensional volume, meter by meter by meter cubed. So that's a tricky one. The prism is laying on its side, so we have to do all that. There we go.